if you were gone on Friday, we did a worksheet where you had to create numbers, and you were given a list of numbers, like 4 or 5 numbers, and then you were given 4 rules. And the rules were, you could multiply by 2, you could divide by 2, you could add any number that you already have to any other number you already have, and you could subtract any 2 numbers that you already have. So we're going to use this idea to find the sine, cosine, and tangent of angles that don't appear on the unit circle. And we're going to do the easy version today, and the easy version focuses on addition and subtraction. So if you look at your reference sheet, on the far right side, down a little bit, you see what are called the sum and difference formulas. So if you don't have a reference sheet, you're going to need one. And then there are 3 sum and difference formulas. Actually, there are 6, but each 3 have a pair. So they look like this, maybe, if I can find it. Looks like this. Here are the sum and difference formulas. So the sine of alpha plus or minus beta is the sine of alpha cosine beta plus or minus the cosine alpha sine beta. So each one of these is simultaneously a sum and a difference formula. So what I want to point out is this plus or minus matches up with that plus or minus. So if you're adding 2 angles together, then you add the 2 parts of the equation together. If you're subtracting, then you subtract. But with cosine, it's backwards. The sum formula on cosine is actually a subtraction when you work the problem. And the difference formula is actually a sum formula. So cosine is backwards from sine. So you don't use the plus and the minus at the same time. You use whichever one you need, and just make sure that you line it up with the corresponding sign in the equation. Okay. So if we look at a unit circle, oh shoot. Can I see somebody's unit circle? Take a picture of this. I gave mine away. So the unit circle has 20 different points. 0, every multiple of 30, every multiple of 45, and every multiple of 60. Okay, but the angles in between are not found. We can create those angles because of the sum and difference formulas. And we could prove the sum and difference formulas, but we're not going to bother. So the sum and difference formulas on their own can only find 15, 75, and the corresponding angles in all the other quadrants. So I could find this angle, any of those. And that's it. And that's because there's no way to create an angle that's not one of those red lines using 35, 45, and 60. There's just no way to do it if all you are allowed to do is add and subtract. So most of our answers today are going to be very similar to each other. They're pretty much all going to look the same. The signs are going to be different. And then tangent's a whole nother monster that we'll deal with. Okay, so for example, let's find the sine of 15 degrees. Well, that doesn't show up on the unit circle. But can we create a 15-degree angle by adding or subtracting any 2 angles that we already know? So I could do the sine of 45 minus 30. Is there any other way? How else could you create 15 degrees? We could do the sine of 60 minus 45. Do you want to know a really bad way to create 15 degrees? We could do the sine of 225 minus 60 minus 60. So I'm down to 105 minus 60 That would be 45, oops, minus 30. That would be a really bad idea, because every time you add an addition or a subtraction, you have to use the equation again. So that has 1, 2, 3, 4 subtractions. I would need to do 4 equations in order to figure this out. Now, we're starting really basic. Sum and difference formulas are easy. When we move on to half angle and double angle, and then when we combine the two, things are going to get quite complicated. But today's really simple. Well, except for the tangent. But sine and cosine are really easy for today. Okay, so it doesn't matter which equation we use. We prefer a short equation. Now, let's look at this one. Alpha would be 45 and beta would be 30. And this is a difference formula, so I'm going to use sine, and the symbol between the two parts of the equation is going to be negative. Does everybody understand why? The difference formula is on bottom, so over here, the negative is on bottom. If you're doing a cosine difference, then you actually use a plus. So whatever your equation says, you match that up with the particular formula you're using, and that's the sign that you have to use. Now, if you notice on tangent, the top is plus or minus, and the bottom is minus plus. So tangent, you do one of each every time. Okay, so I'm going to write this out. Sine of 45 minus 30. 45 is alpha, and 30 is beta. So if we write it out, the sine of 45, so that's this portion, cosine times the cosine of 30 minus the cosine of 45 times the sine of 30. Where can I put that? Now, we look up each part, and then we just have to simplify a fraction. What is the sine of 45? We go to 45 degrees, and we look at the y value. So root 2 over 2 multiplied by, what's the cosine of 30? So we look at the x value of 30 degrees, root 3 over 2, minus cosine of 45, root 2 over 2, times the sine of 30, which is 1/2. Root 2 times root 3 is root 6 over 4, minus root 2 over 4. So I have root 6 minus root 2 over 4. That's easy enough, right? Now I'm going to do the same thing using a different set of angles. So I'm going to change my alpha to 60 and my beta to 45. Sine of 60 is 1/2 times the cosine of 45 is root 2 over 2. Wait, did I do that right? And then I'm going to subtract. No, hold on, I screwed something up. Sine of 60, I did that backwards. So sine of 60 is root 3 over 2. Cosine of 45 is root 2 over 2. And then I'm going to subtract the sine of 45, which is root 2 over 2, or cosine of 45, cosine of 60, sine of 45. I'll get this right. You just wait. 1/2. And either way, I get root 6 minus root 4 over 2. And if you're limited to the sum and difference equations, the sine and the cosine will always be some version of this. Oh, I'm sorry. Root 4, thank you. Oh, and this is, boy, Is it Friday yet? It's Wednesday, though. It might be Monday to you. It's Wednesday for me. She just figured it out. So no matter which sine or cosine you do on this worksheet, you're always going to get root 6, root 2 over 4. Just the positives and negatives will change. Okay, so that's nice to know. All right. Do you want to see another one of those? Maybe we should do a cosine. Okay, we'll do one cosine and then we'll do a tangent. Tangents are really nasty. So, well, it's optional to do the tangents. Just like everything else. Okay. Cosine of 105 degrees. I think this one's on your worksheet. How would we create 105? 60 plus 45. So I write down cosine of 60 plus 45. Okay? And then I fill in the formula, and is this a sum or a difference formula? So it's the top portion of this equation. What is the sign on the top portion of that equation? So the sum is on top, and it says we use a negative when we fill out the formula. And notice the sine formula is sine cosine plus cosine sine. The cosine formula is cosine cosine and then sine sine. Okay? So the pattern changes when you switch from cosine to sine. All right. Cosine of 60, cosine of 45 minus sine of 60 sine of 45. Everybody understand that? Now we just read the values off the unit circle. Cosine of 60, root 2 over 2. Oh my goodness. Sorry. Cosine of 60 is 1/2. So 1/2. Cosine of 45 is root 2 over 2. Minus sine of 60 is root 3 over 2. Sine of 45 is root 2 over 2. And I have root 2 minus root 6 over 4. That wasn't bad, right? Okay, tangent. There are actually two ways to do the tangent. Tangent is the sine value divided by the cosine value. Okay? Someone want to close that door. And it's kind of up to you which way you want to do this. The tangent formula is messy. The sine formula is easy, and the cosine formula is easy. But no matter which way you do it, you're going to have to end up doing a little trick. So, I guess it doesn't matter which one we use first. Let's just try finding the sine and dividing it by the cosine. So if we had the tangent of 105, that's the same thing as the sine of 105 divided by the cosine of 105. Right? Well, we already know the cosine of 105. What is it? So we're going to have something divided by root 2 minus root 6 over 4. Everybody okay with that? Now let's calculate the sine. So 105 was created using 60 plus 45. This is a sum formula. Is the sign in the middle positive or negative? On the sine formula, it stays positive. So sine of 60 cosine of 45 plus cosine of 60 sine of 45. Oh, did I do that right? Yeah. What is the sine of 60? Root 3 over 2. Cosine of 45? root 2 over 2 plus cosine of 60, 1/2, sine of 45, root 2 over 2. So I end up with root 6 plus root 2 over 4. So here's my sine value. Here's my cosine value. How do you divide two fractions? You flip in times. Am I going to flip the sine or flip the cosine? Flip the cosine. So I'll take this sine value, multiply it by 4 over, well, it doesn't really matter. And the 4's cancel. Okay? And I'm gonna switch these around so they match those. So I'm just gonna flip the 6 and the 2. So root 2 plus root 6 over root 2 minus root 6. Easy so far, right? But I'm not allowed to leave square roots in the denominator. Okay? So normally, if I were to have 1 over root 6, what do? Just times it by root 6. But now I have 2 square roots in the bottom. So let me clean this up, and then I'll show you how to fix it. And this is, I'm not going to lie to you, this is painful. But it's a really common thing to need to be able to do. So, we need to get rid of both square roots. And the only way to do that is to multiply it by its conjugate. Do you remember what a conjugate is? Remember back when we did quadratics and we had x plus 3? What is the conjugate to x plus 3? X minus 3. And what's the nice thing about conjugates? What cancels? The middle term cancels. So I get x squared, and I get minus 3x and plus 3x and minus 9. So if you have conjugates, then the middle terms are going to cancel, and in fact, you can just ignore them altogether and not calculate them. And we've done multiply by complex conjugates. This is kind of radical conjugate. So what is the conjugate to root 2 minus root 6? You just change one sign, not both. You change the middle sign. Yeah, if you change both signs, then you kind of doubled your conjugate, and it's not going to work out that way. Oh, okay. Now, if I multiply the bottom by the conjugate, I have to multiply the top by the same conjugate. So this is root 2 plus root 6. Now, there are 4 multiplications happening in the denominator, and I only need 2 of them. I need this multiplication, and I need that multiplication, and I can skip the other ones. Because if you notice, this times that is going to be root 12, and this times that is going to be negative root 12, and those are going to turn into a 0. Okay, what is root 2 times root 2? Root 4, which is 2. That's nice. What is negative root 6 times root 6? Negative root 36, which becomes 6. So that wasn't too bad. So it's just negative 4. Now on top, are we going to have a cancellation? No. We're going to have to multiply it all the way out. But we kind of know the pattern. It's going to be first times first plus double the first times second plus the second squared. So this times this is just going to be 2. And this times this is just going to be, so 2 plus 6. And then the other 2 are actually the exact same thing. So we have root 12 and root 12. Oh, did I wrote those wrong. Sorry. This and that. There we go. So I have root 12 and root 12, which is actually 2 root 12, because it's root 12 plus root 12. So it's plus 2 root 12. But does root 12 contain any perfect squares? What perfect square goes into 12? 4. So, and remember, if you factor it out, 4 and 3, 2 and 2, do I have any pairs? I can pull out a 2, but I already have a 2 sitting out there. So it's 4. So this is 4 root 3. And hopefully these numbers are going to be small enough you can just say, oh, there's a 4 inside there, and you square root the 4, which means you pull out a 2. So I have 2 plus 6 plus 4 root 3. So 8 plus 4 root 3. Almost. I can cancel the 4s. So, right, it's going to be negative because of this. And that cancels that and cancels that, and I'm left with well, I pulled right. Well, there we go. Now I did it right. Okay, that's one way to do it. Okay? It's not no step is bad, it's just kind of a long process. So let's actually try to use the tangent formula. So here's the tangent formula. So we want the tangent of 105. Tangent of 105. And the difference is if you use the sine and cosine, then you only have to do that that fraction flip once. But if you use the tangent formula, you actually have to do the flip 4 times. So you're doing the same thing, and it really depends on your personality which one you like the most. So let's try it. How do we create 105 degrees? So the tangent of 60 plus 45. Okay, now notice this plus or minus matches that plus or minus, and the one in the denominator is opposite. So we're doing a sum formula, so we're going to use the top sign. The numerator will be positive, and the denominator will be negative. So tangent of alpha, which is 60, plus tangent of beta, which is 45, over 1 minus tangent 60, tangent 45. Everybody understand that? Now we're going to have to find lots of x's and lots of y's, and it's always y times the reciprocal of x. So tangent is sine over cosine. You take the y value, you divide it by the x value, which means y value times reciprocal of x value. Okay? So here is my 60 degree, and here is my 45 degree. So tangent of 60, root 3 over 2 multiplied by 2 over 1. Those cancel, and I'm left with root 3. That wasn't too bad. Plus tangent of 45. Well, it's root 2 over 2 times 2 over root 2. Everything cancels, so I'm left with 1, which is nothing in terms of multiplication. So plus 1 over 1 minus, I already know what the tangent of 60 is. It's root 3. So that saved me a little bit of time. And I know the tangent of 45 is 1. So that's just root 3 plus 1 over 1 minus root 3. Now that doesn't look anything like what we had before, right? Well, it actually is the same thing, but we're not allowed to leave radicals in the denominator, so we need to times by the conjugate. So I'm going to multiply by 1 plus root 3. 1 plus root 3. What's that? The root 3 times 1? The 1's fine. The root 3 is the problem, but if I times just by root 3, then that 1 will become a root 3. And then it won't work. Yeah. So Hannah looked at it and said, last time we had 2 radicals, and this time we only have 1. Well, it's not the 2 radicals or the 1 radical that's the problem. It's that it's an addition or a subtraction. That's the issue. It's a binomial, 2 terms. So whether both of those are irrational or not, you're always going to multiply by the conjugate because you have a binomial. The only way to get rid of a radical in a binomial is to multiply by the conjugate. Okay, the denominator is really simple because they're conjugates. First times first is 1, and then second times second, negative root 9, which becomes negative 3. And then on top, we have 1 plus 3. And then we have 2 versions of this, which is going to be 2 root 3. Now this is kind of nice because does root 3 simplify? No. So this gives me 4 plus 2 root 3 over negative 2, which is exactly half of what we had before. So I can pull a 2 out of everything, and I'm going to move the negative to the top. So negative 2 plus, minus root 3. And that's the same answer we had before. And your tangent is always going to look something like that. 2 plus root 3, negative 2 minus root 3, negative 2 plus root 3, somewhere in there. I think they all look like that. All right. Do you feel sufficiently prepared? So I don't care which way you do the tangent. If you want to find the sine and then find the cosine and then multiply or do y times the inverse of x, that's okay. If you want to use the tangent formula, that's fine too. It doesn't matter. And you'll never have to memorize these formulas. You will always have the formula sheet. So that's good news. Okay. Good luck. Tomorrow we will do half angles or week of math.